Alright, flip it to the back. Now we're going to talk about our mean and standard deviation for each one of them. The mean for binomial, you actually told me that equation because of this. So where does it peak? Well, I take how many I had and my probability and figure out where it peaked. That is what the mean is. So this one says if I count x, so if I say I'm doing x, I would typically write it as v of x equals. I don't care if you write the x there if we're only doing like one problem though. And I just do n times p. So that helps me figure out where it is that I peak, which is my mean. Standard deviation also accounts for probability of failure. How do I find probability of failure? You don't need to know this process of why this is the answer, or why this is the equation. But how do I find probability of failure? 1 minus p. But how do I always find standard? What's always the last thing I have to do to find standard deviation? So we're still finding the square root. So I'm accounting for my trials, probability of success, probability of failure, and taking the square root. So back to the graph that we've been talking about, the one from yesterday, which we already know the answer of what the mean is. What was our n from that problem? The 7-sided alpha star. Yesterday, how many times did I roll that die? 7 times. What was my probability of success? Which gives me, and what are my units going to be there? I had 3 what? That were in general, what word is going there? My success. What's my symbol for standard deviation? What's my equation? N times p times 1 minus p. So in this situation, my n is 7, my p is 3 out of 7, which makes my n minus, or 1 minus p what? What's the complement of that? So our graph yesterday from 0 to 7 peaked at 3. And what do we get as our standard deviation? Three oh nine what? 309.3. Stars. And sometimes this will be written as like the trials and be like rolls, because it's the rolls that were how many rolls were success, 3 rolls. So this one, it means it varies by an average of 1.3093 from the mean of 3. Alright, so interpret. We are just very, very, very slightly tweaking our interpretation for mean sentence that we already have. What does our other interpretation for mean start with? If what? me something were randomly selected. Well, here we're repeating our trials. So in this example, how many trials did I do? 7. So we're repeating the fact that we're doing 7 over and over. That to me sounds weird to say if many rolls of 7. So I'm just switching the many to where it makes more sense. I don't care if you write it that way. So if we randomly selected and we're selecting, inserting like quote unquote the experiment, and the experiment was the entire 7 rolls. So if we randomly selected whatever our total trials is, which in this case would be if we randomly selected 7 rolls of the die many times. So I just put it afterwards because I think it makes more sense there. I don't care if you put it before, it doesn't make that much sense verbally. Then what? So think about our sentence from interpret me. We expect is what I use. Same thing, but the word I usually use. What? About what? So what's going to go here? Average number of successes. And then the part that you guys tell me to write to what? And then what's the only part that I haven't written? What do I plug in here? My mean number. So I'm just going to write u. If you'd rather write mean number, you're actually plugging the number in there. And the what of that? So if we randomly selected 7 rolls of the die many times, we would expect the average number of stars to be about 3 stars, or 3 rolls. And then continuing that, and we expect what from there? The number of trials successes. I'm looking at the wrong one. Successes, which that's where, I mean, technically I could write it as trials if we did it rolls. To what? From what? So bringing back in, I always have people who have this, and I think it's because I don't make a big enough point here. We expect the number of to be different, right? A lot of people put the word average here instead, but what is the true definition of standard deviation? Average distance from the mean. To vary from the mean by an average of, and that's why average goes with this one and not that one. We're varying from it by an average of. So from the mean, whatever the mean number is, and that units might get a little bit duplicative, like it kind of says up there. It's like stars ended up being our successes and our units. So vary from the mean of that by, and then this is what we just talked about, what? An average What word? About, and then number of units. So if we randomly selected 7 rolls of the die many, many times, we expect the average number of stars to be about 3 stars. And we expect the number of stars to vary from the mean of 3 stars by an average of about 1.3093 stars. Sounds like a lot of stars there. So like in this one, it's never so. I wouldn't count off if you didn't put stars versus units on this problem. Questions with that? It's the same thing, it's just applying it to the fact that we're doing a group of them and not just one. Alright, so now geometric. If I am rolling a die and I want to get a 1, on average, how many times do you think it would take me for the first time I saw it? Why 6? So if the probability of something was 1/4, on average, how many times do you think it'd take me to get it? 4. What are you doing with the probability? What are you doing with this and this? Flipping it. What if it's, what does it mean to flip it? So I'm taking this. So my answer is the mu. I just 1 divided by whatever my probability is. There's a 1 in 12 chance. On average, it's probably going to take me about 12 times to get them. That makes sense. Binomial makes sense. Standard deviation of y is not one of those that's the reasonable, like, oh, I see why that is. It's kind of just one of those where this is the answer. It's not worth our time to get into why it's the answer. So I left space for interpret mean and interpret standard deviation, but let's go ahead and go straight to filling it in, and I'll come back and write the interpret. So in Dina's favorite game, there are 20 identical cards to choose from that are mixed up and replaced each time. And they're selected without looking. So that whole first sentence is just making sure to justify that it is what? Say it again. Independent. 13 of them allow the player to collect tokens. On average, how many cards will she have to select in order to select a token? So this is geometric. We're deeming success as what? Getting a token or a card to get a token. Token is fine with me though. Just in case somebody's trying to read my terrible handwriting. I would have just written token though. What's our probability of getting a card to get a token? So, on average, the other way this is going to say is it would say, how many would we expect to have to do to get our first? So that's another way to word average, is how many would we expect to have to do? So this is telling us I'm doing the mean. What's our symbol for mean? Mu. What's my equation for mean for geometric?
1 over 2.
So essentially I'm just taking that and flipping it. 20 over 13, which ends up giving us what? What would not really make sense here? First reaction, what should I write right here? First reaction might be tokens, right? But why would that not make sense? It's going to take me that many tokens to get one token. Does that make sense? That's how many trials it takes me to get that many tokens. And then standard deviation. What's my equation, or what's my symbol? Sigma. What's my equation? Square root of 1 minus p over p squared. You have to put your 1 minus p in parentheses if you don't convert it. So what's 1 minus p? I usually just go ahead and write it like that if it's something this easy. It doesn't really change anything though. I want everybody to make sure you actually type that in, so I want to make sure that we're typing that in correctly. What is 0.9 what? I don't know what to. And so if my units up there were cards, my units also here are cards. And I want to make sure everybody's typing that in right. It's parentheses things that could become an issue. So if you do something wrong, either grab somebody else's calculator and hold them side by side and see what you didn't do, or call me over and I'll make sure I see what you did do. And honestly, in a problem like this, the way I usually do it is I do this first, and then I type that divided by my second answer, and then take the square root of it, and I do it in 3 pieces. Questions with geometric mean standard deviation? I want to end with the interpret thing because I want to make sure I get to this last part. Writing down and interpret doesn't take much.